Okay, let's take a look at another problem so that you can understand things a little bit better. So I'm just drawing up the question right over here. Let's say this is our question. Sorry, I'm not typing out the question. This is not going to be very fancy. I'm just going to call this up with freehand right. There you go. This is a fixed support right over there. There's another fixed support right over here, and at here we have a guided roller. Okay, there we go. So these are the things for this question, and here we have 5 kips instead of 10 kips, and here we're going to apply a 3 KFT kip per feet UDL right over there. Okay, so the names are going to be the same. Here we have A, we have B, then we have C, and then we have D point. So right now you can see that there are 2 unknowns, so let me just show you the unknowns. First one is theta B is an unknown, and since there's a guided ruler here, there's going to be the UD. So there are 2 unknowns. So since there are 2 unknowns, there are going to be 2 deflection diagrams. So we're going to be needing 2 deflection diagrams. So at first, let me just draw up the first deflection diagram, which is going to be due to the theta B. So we already know how that is going to look like. So this is going to be the theta B deflection diagram. Since this is for theta B, so the rotation is at B, so all other subsequent ends are going to be having a fixed end. There you go, a fixed end. There you go, a fixed end. There you go, another fixed end. There you go. And now let's draw up the deflected shape. So if we draw up the deflected shape, this will become something like this, and sorry, I just got it on the side. There you go, like that. Right? This is what it is going to be. Because there is a moment at this direction. This is the same as before, the thing we have done before. It's because of a moment that is rotating like that, and we call this theta B. Now that's done. We're going to be drawing up the forces in accordance with the deflected shapes. So here we have S4, then right over here we have S3, then here we have S3 prime, and in this direction we have S4 prime. Similarly, in this direction we have S4 prime, and in this direction we have S3 prime. Okay, so those are the rotational forces. This time we're going to also need the vertical force, because there is a displacement at D. So here we just actually need this and not the other ones, but still I'm going to draw the other one. So here we have S2 in this direction, then we have another S2 in this direction. Similarly, we have another S2 right over here, and then we have another S2 right over here, then we have another S2 right over there, another S2 right over there. Okay, so those are the S2s. Now this diagram was for the case theta B. So this diagram is for case theta B. Alright? Okay, so let me just give it a boundary. There you go. This one is for case theta B. Now we're going to draw up one for case UD. Case UD. There you go. There you go. Now since we're considering the D point, so all the adjoining points with D point are going to be considered fixed support. So if we show the fixed support with a different color, let's say the only adjoining point is the B point, so there's going to be a fixed support. This is what we're going to consider, that this is a fixed support. Now if we consider that to be a fixed support, the deflected shape is going to be something like this. Okay. So this is going to be the deflected shape, and if that is the deflected shape, the moments on here are going to be like S2 and S2 there, and another S2 on this direction, and we're going to have S1s as well. So we'll just change the color. The S1 forces are going to be on this direction, and another S1 force is going to be on this direction, S1. and so on. And if you are having a hard time understanding why I'm drawing the forces in this direction, you can always go back to the slide where we have the force diagrams, and you can just match them up with this one. Okay, you just need a little bit more practice. See, there are the diagrams. You can see where the S2 is, where the S4 is, where the S3 is. So these diagrams are the ones that I'm following here. So you just need a little bit more practice. If you are still not being able to follow up, okay, you just need to come back here, take a look at the diagram, and then go back up here and take a look at this as well. Okay, right over here you can see the end that has moved is carrying positive S1, and the end that did not move is carrying a negative S1. So if we go back to the diagrams, there you go. So we have an end that is moving. So the moving end, you can see that is carrying a positive S1. Even if you consider the first one, the VA diagram right over here, you can see the at the end that is moving is carrying a positive S1. See, so that is how I have drawn out the diagrams right over there. Okay. So now we have two case diagrams that are ready. Oh, sorry, I did not get the proper supports on the other parts. There you go, we have a guided roller here and the fixed supports right over there. Okay, let's call this case UD. So we have case theta B and case UD drawn right over there. Now we can go and formulate our equations, the equations that are going to help us solve this problem. Okay, so let's go. Let's say MB is equals to 0. Since the unknown at point B is a rotation, we're going to consider MB. We're not going to use any other equations right here. Okay, alright, so here we have, let's see, one S3 prime, another S3 prime, and another S3, and they're all anti-clockwise, so they're going to be all positive. So we have 2 S3 prime plus S3 multiplied by theta B. Okay, and right after that, let's give a plus here. Okay, there's a plus. So right over here, if you're wondering, this is actually the K. Let's see. Okay, this was the K right over here for the B point, and let's see. So that is for the B point, so that's the K B point, and here we go, we have theta B right over there. Now here we are gonna have a negative S2 right over there. So negative S2 into UD. So this K is for D. Okay. Since here is a rotational unknown, we are using K theta equals to M, and since here is a horizontal unknown, a force unknown, we are using the KU equals to F analogy for that point. So this was for the B point. Okay, let me just put a marker. Now this segment was for the B point, and this segment is for the D point. Okay, so that is why these two kind of things are being used here. Okay, so now that we have talked about that, let's move on. So this was our stiffness into displacement vector, stiffness into displacement vector. So all that's left is the Q minus F. So Q here is 0, as you can see, and the value for F here, let me calculate it for you quickly. We have a 5 right over there and the 3 KFT right over there. So this is going to be minus 21.9. There we go. So we have MB. But you can see we have only one equation and two unknowns. So we are actually going to be needing two equations to solve two unknowns. Right now we have completed MB. So let's see which X equation we can use. We can use an f of x at D. We used MB because there was a rotational unknown at B. That's why we considered MB. And since there is a horizontal displacement and horizontal unknown at point D, we're going to be placing the horizontal force equilibrium at D equals to 0. Okay, there you go. So here you can see at B point, at B point in this diagram, the force is S2, and that S2 force is moving in the negative direction. So that is why this is going to be a negative S2. There we go, a negative S2. Okay, let me check if I draw this thing wrong or did I draw it right. So we have this, okay. Let me just check quickly. Alright, so S2, this location is negative. This S2 is negative, but when it's written like that, it's positive. Okay, so that one, if we place this member like this, it'll give a shape like this. Okay, and right over here we're gonna, let's match this shape. Okay, so the one that's going to be here is in the positive, and the one that's going to be in this direction is going to be negative, right? Okay, let me see one more time. That is going on the positive direction, that is going on the negative direction. Okay, so at B point, this is not going to be a negative S2, this is going to be a positive S2 into theta B plus, okay, where we are choosing the rotation here. The rotation was S2. Oh, we're not choosing the force, we're going to be choosing the rotation here because we're multiplying it with theta B. So only rotational stiffness can be multiplied with theta B. So we're not going to be considering the forces here. Sorry, I just got that confused a little bit. Okay, I usually don't use the equation method. It is not my favorite method. It's not my go-to method. Okay, so we have a negative S2 right over here. We have a negative S2 because we're going to be focusing on this diagram when we are doing the f of x at D. We're not going to be focusing on the case theta B diagram. We're going to be focusing on the case UD diagram. So at case UD diagram, you can see there is a positive S2, a positive rotational stiffness, which is S2 right over here. So this S2 is being considered here. So that is why there is a negative S2 and theta B. And then we're going to be adding a plus. Then this is for the D point. At D point, we have a positive S1. So that is we're going to be taking a positive S1 multiplied by UD. There we go. Equals to 0. Value of Q is 0 minus, if we calculate it up, we're going to get 15. Okay, so we have equation 1 and equation 2. There you go. So we have two equations and two unknowns. So from here we can easily calculate the theta B and the UD. So for the help of calculation, let me just say that S3 is equals to 20,000 and S3 prime equals to 10,000. You can use the values here to calculate the values of theta B and UD. Okay, so that is how you use the equation method. So when we are doing summation of moments at B, we're going to use the case theta B diagram, and when we did the equation f of x at D, we use the case UD diagram. Okay, so as many unknowns there are going to be, as many diagrams there are going to be. In the previous example, we saw that there was only theta B absent. That is why we only had to use one diagram. But this time we saw that there are two unknowns, so we had to use two diagrams. So if there are three unknowns, we have to use three diagrams. If there are four unknowns, we have to use four diagrams, and so on and so forth. Okay, so that is why the equation method is quite hectic and can be quite confusing, but it actually differs from person to person. using hand calculations. But when we are going to be applying this in a computer programming, or we're going to be using a software, the software is not going to be considering the diagrams, it is going to be considering the values, because as humans we can conceive diagrams, we can see, draw diagrams and understand diagrams even without values, but the computer and the computer programming language does not understand graphical representations without any values. For example, if you give it a value of 2 by 2, or if you give it a coordinate of 3 by 4, it can show you a graphical representation. But if you give it a graphical representation without any scale or any values, it will not understand what that is. For example, if you draw a picture of a sun and a picture of a mountain and give it to your computer programming, it will not understand what that is. But if you give a coordinate line coordinates that will make up a drawing of a mountain and a sun, your computer programming will be able to perform that. So that is why it is quite difficult to go from diagrams to values in computer programming rather than going from values to diagrams. Okay. Alright, I'm not saying it's impossible. There are possibilities, but some things are quite easy to do and some things are a bit complex to do. But there are always been people who are actually good at complex things rather than easy things. So it actually depends on person to person. It varies from person to person as well. Okay, so that is it for this video. Thank you very much for watching, and I hope you got to learn something new.